Right, we'll get started. Thanks for joining us this morning. We have a really good session this morning. Just like the way as you get on planes, to let everyone know, this session is about understanding database options on AWS. If you are here for database options, you are in the right place. I have a great honor and pleasure to join me this morning, three really good speakers. So hopefully I'll set up the stage for them and they'll take it from that point onwards. Let's see, how does this work? Two, okay. Ooh. Ooh. There you go. So today's discussion is about understanding database options. In our classic retail mindset, we offer you a lot of choices on AWS, and we will describe the different choices that are available to you to make great applications. As I was mentioning earlier, I have the distinguished honor of being joined by a couple of really excellent speakers. Kimo Rosenbaum from Edmodo will join me after my initial introduction. He'll be followed with Jay Edwards from the Obama for America campaign, a very interesting use case. And he'll be followed by Andy Scalett, CTO of Brand Verity. So great speakers. Hopefully I set it up right for them. Each one of them will speak about a particular way in which they have thought about their application and help to optimize manageability and scale from an Edmodo perspective, a great social application for schools and students. Talking about application velocity and how do you get to scale in a short amount of time. That's Obama for America campaign. Jay will speak to it. And looking at the different options, there is always a sort of a pseudo-religious debate on YesSQL versus NoSQL. Figure out what's right and which one to use when. That'll be Andy Scalett from Brand Verity. And we'll take Q&A towards the end. There'll be handheld microphones. I'll be running around with handheld microphones. So if you have questions, please save them towards the end of the presentation. We'll talk about it. So before we begin to the database options in detail, I have the pleasure to sort of recap what was discussed in the keynote. If you all attended the keynote, you would have seen today we added one more option to the list of options available to you. We are introducing Amazon Redshift. Redshift is a new database that's made for data warehouse. It allows you to go from small number of terabytes to a petabyte scale data warehouse. You can start small and you can grow as big as you would like. Just like the way other options that we provide, we give you full automated manageability and deployment. And the best part is it's completely standards based, which means all your existing relational tools, such as MicroStrategy, JasperSoft, Business Objects, Cognos, and all of those things, they will work, just that they will work a lot better. Here's a quick high-level overview of how it looks like. It's a new database engine that uses massively parallel processing architecture, which means it can use as many resources that you configure it with. So if you have a terabyte of data or 10 terabytes of data, then you can put it on a single node or a couple of nodes versus tens of nodes, and that will allow us to use all the different nodes that are available. You can configure up to 100 nodes to reach a petabyte scale. We have done a couple of neat things on this product. We are using columnar storage format, so your queries are processed with nearly 10 times less I/O than the traditional data store. We are using advanced compression technologies, so the amount of data that's stored on the disk is a lot smaller than actual leaf node that you might be feeding us. We also are using, as I described earlier, massively parallel processing, which means if there are 10 nodes or 20 nodes or whatever you allow it to have, then it can use all the resources to serve your query with the consolidation taking place at the leader node level. As I said earlier, it works with all your popular engines. So if you have business users who are familiar with MicroStrategy or JasperSoft or business objects, you don't have to change a thing for them. Behind the scenes, you can go from something that's expensive, slow, and a bear to maintain to Redshift. And all of a sudden, your users will see much better performance. You will have headroom to grow into data. In terms of pricing, a lot of the details were disclosed in the keynote. I'll just highlight from a 3-year reserved instance perspective, for a terabyte per year, you'll pay just under $1,000. That works out to be about 23 cents per hour, if I'm not mistaken, 22.8, I think. So that's an exciting news. We are adding to the list of options. Now let's get to the real task at hand. All of us, just following the theme of Mars curiosity, the mission is clear. We have to produce from zero to an app in some number of minutes, possibly days, some number of users to millions of users in days, possibly in months, and perhaps go from nothing to IPO for those of you in the startup arena in months. Well, that part is totally up to you. The other two, AWS can help. So we can help you with our tools, we can help you with our systems, and we can help you with our databases. Let's talk a little bit about focusing on your app. This is typically the database architecture that looks like, most application architecture looks like this. There is a load balancer where you are looking at how to distribute the incoming load, figure out what to block and what not to block. It could be possibly a firewall as well. Then you have an application tier where much of your innovation goes, and lastly, the database tier. Now, this stack over time becomes your stack of worries. What I mean by worry is you start with security, scale, and availability at the load balancer level. Then you have to think about innovation, scale, performance, availability, and so on and so forth in the application tier. And as you move further down, your number of issues start to multiply. You look at security, innovation, scale, transactions, performance, durability, availability. Our view is that you should really focus on your time on the top 2 layers and help offload much of that administrative task over to something that can do it really well. In doing that, you have, continuing the theme of Redshift, you have a list of options available to you. You can think about SQL versus NoSQL architecture. Why would you choose one over the other? Let's talk a little bit more in detail. You could choose to do it yourself for those of you who have the skill set, time, and resources available. Again, it's a very good option depending on your application. Or for those of you who want to focus a lot more on your application, we provide fully managed services as well. You could choose to go with a low-cost option or a high-cost option. Unfortunately, the high-cost option is not available on AWS, so we'll take that off the table. Looking at that in detail, let's think about what is available if you wanted to do it yourself. Plenty of choices. You could go with MySQL, very popular open source stack. You could manage it on your own. We give you a variety of instance classes, storage options available to you. You could also go with various versions of Oracle, Standard Edition, Enterprise Edition, and so on and so forth. SQL Server, all the different flavors are available. You could also look at more emerging things like MariaDB or a more popular Postgres. So the number of choices available to you when you take things under your control is pretty high in terms of being available and do-it-yourself model. You could also choose to offload some of those administrative tasks to AWS so that we can automatically apply the patches, the upgrades, take care of scaling, and all of that stuff. That's MySQL, Oracle, and SQL Server. Those are 3 choices that we offer today. In a similar way, architecturally, once you think about SQL is not the right choice for you, and we'll talk a little bit more about why would you choose to go with a NoSQL option, you could go with a number of really good choices. MongoDB is available on AWS, Cassandra, Redis, and Memcache. Each one of these engines gives you a specific flexibility and control and power that you can deploy your applications really well. You could also choose to go with, just like the way we talked about fully managed relational database services, you could go with a fully managed NoSQL service. We offer a DynamoDB. We'll talk a little bit more about what that gives you. ElastiCache from a Memcache service perspective. SimpleDB. All these choices are available to you today to offload your stack of worries to AWS. So which one should you choose? Let's think about the kind of questions that I often get asked by customers. I often get asked by customers, should I use SQL or NoSQL? Should I use MySQL on EC2 or on RDS? Should I use MongoDB, Cassandra, or DynamoDB? Should I use Redis or Memcache or ElastiCache? I take a step back and I always think about, are these the right questions? I think the right questions might be really to focus on your app. Before you pick the tool, let's think a little bit more about the type of application you're building, the time in which you're building, the customer you're trying to serve, and the scale at which you need to operate. So first question might be, what are my scale and latency needs? How fast do I need to grow? How quickly do I need to serve these requests? What are my transactional semantics? How do I need to think about applying transactions and possibly rolling back? Is there a complex multi-table kind of query involved? Or is it simple key value store? Those are the kind of questions first you ought to be thinking about. Consistency plays a huge role. Do you want to be able to write a bunch of transactions and be able to read in a consistent way across transactions? That places some restrictions on the list of choices that you have. You should also think about what your read-write mix looks like. Is this a read-heavy application? Is this a write-heavy application? What kind of storage do I need? Is it lots of storage, or is it small amount of storage? And how often am I accessing the data? From an IOPS perspective, is my application consists of small number of transactions, infrequently accessed, but it's mission critical, or large number of transactions, frequently accessed, also mission critical with minimal latency? Those are the kind of questions that lead you to think about the different choices that are applicable to your applications. Here is some factor. Again, I would not portray this to be an exhaustive list, and I'll highlight a couple of them. I think it's important for you to sort of create your own vectors of evaluation, if you will. It's not sufficient to just think about a particular technology and figure out how to fit it. It's really important for you to think about the list of characteristics that you want to put in your application. For example, you might think about the business logic of your application. If it is involved multiple transactions and if it involves normalized tables, you might want to go with the SQL approach. But if it's a web app with lots of users and that's scaling really quickly and it's a shopping cart style application or it's a game style application, you might want to think about NoSQL as an option. Same is true with scale. Do you want to be responsible for managing the scaling aspects? Do you want to build your own infrastructure, code, and scripts and other things to scale the application as your business grows? And many of us are fully capable of doing that, and that's fantastic. Then you can use the SQL approach because SQL gives you that power and tooling available to you. There are also tools available on AWS where you can offload the scaling to AWS, particularly in the case of DynamoDB, where the scaling is the engine's problem. You just tell it how fast you want to scale, how far you want to scale, and it takes care of it. Availability, again, is a key criteria. If you are an application and you're expecting the availability constraints to be specific, then under the SQL architecture, you will have to assume there will be a failover. It's not failure, but there will be a failover. So you have to architect your application to make sure that you can operate it on multiple nodes. And if you would like to, you can take control of it from a failover strategy perspective, or you can offload it to RDS. So these are architectural choices that we encourage our customers to think deeply before picking a choice, because there is no right or wrong answer. There's only a list of acceptable compromises and acceptable optimizations that you do to build your application. It's possible to use both of them. So you, based on the architecture you do for the front-end high-velocity transactional application, you could use a NoSQL with more durable business logic, complex transactions backed by SQL architecture. And we'll talk about that in the use cases. Factors to consider, again, do it yourself. Other things to think about, replication. Would you like to be granular, app managed, or would you like it to be automatic? You can think in terms of resources. Do you have the skill set available on your team in order for you to make it work? Or do you want it to be offloaded? What are your time to market considerations? Do you want the application to be built and deployed in a short amount of time? Or do you have time to make sure that it works right and it works to your satisfaction? Those are the factors that will play a role in making this. Here are a couple of key things to think about. First thing I would highlight is RDS. For those of you who don't know this, it's Amazon managed, fully managed SQL database service. It gives you a choice of database engines. It is simple and it's really push button style. With a single call to the API or a single push button on the console, you can actually deploy databases starting with 5 GB all the way up to 1 TB with standard storage and provisioned IOPS storage and so on and so forth. You can do that all without any operational burden. It's really driven by the console. What it allows you to do is to focus on the left-hand side, which is really around optimizing the schema, query performance, and things like that. And we'll have a couple of customers talk through that. Offload all the different issues related to backup and recovery, patching, configuration management, software upgrades. All of that can be offloaded to the engine. Now, it does come with some compromise. Many of the things that you would normally take care of as a DBA are available to you. You can manage multiple databases. You can have account management. You can tune various parameters. You can import and export using various connectivity tools. But you do give up some control in terms of having access to the box and having super user privileges. We have to do that so that we can think about security and make sure your box is well hardened and protected. So this is a choice. Again, as a DBA, I'm comfortable not having super user access. I am programmatically creating and deleting databases. I can manage it. I can go faster. Then this is the right choice for you. If you want that level of control and sophistication, you might want to think about doing it yourself on EC2. ElastiCache, fully compatible, Memcache compatible managed service. Again, gives you a lot of flexibility, power from a deployment perspective, and it gives you read scale from making your application go faster. DynamoDB goes to the other end of the spectrum. It's a fully managed NoSQL service where you can store and retrieve virtually unlimited amount of data. Practically, you can go from few megabytes all the way to terabyte. As you scale, the application, the engine will scale with you. You can scale to millions of I/O. You can go with 10 IOPS, I/O requests, or a million I/O requests, literally by turning the dial. You get consistent, predictable performance regardless of scale. That's the beauty of this application, this engine. It gives you single-digit millisecond latencies, so you can predict what your end-user experience is going to be. All you have to do is to dial up. Scaling is the engine's problem, not your problem. You just have to tell it how far to scale. Again, without any of the operational burden. The programming model, a lot of the customers ask us often is, how quickly can I get to do this? And it's relatively simple. It fits on a page. In the interest of time, I'll sort of skip through that. More details are available on our detail page. So who are really successfully deploying these applications? Thousands and thousands of customers are succeeding with these tools. You can do that too. There are 3 highlights here. Edmodo runs a social app on top of our engine. Obama for America reached millions of citizens in a short amount of time, and Brand Verity analyzes billions of ads every single day. They use all these different tools, and I'll let them speak to it. With that, let me introduce you to Kimo Rosenbaum from Edmodo.
I'm Kimo Rosenbaum. I'm actually an infrastructure architect at Edmodo. We'll get into it. So the educational community is really starting to embrace the internet and its power to connect via traditional content delivery like Netflix, YouTube, non-interactive websites, and increasingly content interaction like Moodle, Khan Academy, and social media platforms like Edmodo. So our mission is to connect all learners with the people and resources they need to reach their full potential. So as a social platform, our goal is to help educators harness the power of social media, connects teachers and students, to customize their classroom. Using this platform, teachers and students can collaborate, they can share content, like a video related to a recent lesson, or links to other lessons, and they can even take online quizzes, turn in assignments, and there are third-party apps available like interactive textbooks. We are partnering with places like Khan Academy and whatnot. It's available for various devices like browsers, iPhones, Androids, and whatnot. And it's free for teachers, students, and parents. We have over 100,000 schools globally. It's available in many different languages. 14 million users. I'd say maybe 99% of those are students. We have over 1 million teachers, and we have a lot of parents, and then there are also school admin accounts so they get a dashboard where they can see what their teachers are doing, what their students are doing, and graphs and things like that. So in the past year, our traffic has doubled. And Amazon was really nice because we can scale up and not have to worry about hardware and managing that growth. We can just keep adding capacity and manage our app. Every day, 1 million visits a day. It's interesting to note that our traffic flow is during the school day. So 8 a.m. in the morning until 4 p.m. in the afternoon, our site is at its busiest. And that's really interesting because that means that students and teachers are using it in their classroom and around their classroom. They're actually integrating it into their whole learning process. It isn't something that's just, at nighttime they'll go and do it for a few minutes. They're using it all day long. Our busiest time is Thursday, just before lunch. I don't know why. So like weekends, holidays, summertime, it's very low traffic. This is our architecture on AWS. It's a fairly standard app that you'll see. You'll probably see a lot of these diagrams looking just like this in the next couple days. We are multi-AZ, mostly except for some of our master databases. Each AZ we have the full stack, and it's independent from each other. So if one AZ is having problems, our other AZs can pick up the load. Our web tier, we do use auto scaling. So in the morning, just before 8 a.m., we turn up 100 instances, and those are running all day long. And at 6 o'clock, 7 o'clock, we start downscaling, turning off older instances. This helps reduce costs. We do have a memcache tier running on EC2 that's split between our data cache and our session cache. And we have replicas per AZ to help reduce latency and for failover. If one AZ is down, our entire stack can still operate. Our app is vertically sharded. So what that means is, for example, we have all of our user data in one master database, our comments and posts in another database, file uploads in yet another database. We have maybe, 7 or 8 different sets of data types, each with their own master and their own replicas. We also have what we call ad hoc replicas that aren't part of the normal user workflow. So these come in handy for like our data science folks, our marketing, so they can run long queries that may use up all the CPU, all the RAM on that instance without affecting how our website loads. And we use other services like Amazon CloudWatch, S3, CloudFront, ELB, Route 53, VPC, mostly all of the services. To talk about RDS specifically, some of the tools that we use. So we're primarily RDS MySQL. So some of the tools we use are the restoring from snapshot. That's one button you can say restore from snapshot. So this is really nice because you can replicate your production environment in dev and in QA. So what we do is after a major code push or after a major schema change, let that run for a few days, let users build up data and whatnot. Then we'll take the snapshot, restore it into our QA environment. And so now our QA team has usage patterns for our recent data set. And then in dev, our engineers can play with different schema, different queries, and in isolation and not worry about messing anything up, because if the schema doesn't work out, they can just delete that RDS instance and restore from a known working point. And with RDS, we can turn up an RDS instance for each developer if we wanted to, or if they need multiple instances, they can turn up multiple instances and do their own cluster. Replica creation is another one we use a lot. That's again one button and you have a replica. If we know we're going to be seeing increased load like the beginning of the school year, or if there's a major like teacher conference or some educational event, we can add more replicas to handle like our reads, or if marketing or data science needs something else. We can create another replica and they can do their queries, and when they're done, we can shut those replicas down. Parameter tuning is something we do often. So with RDS, you have an API to change parameters, or you can go through the console and change parameters. These are things that you'd have to do, on the file system with traditional MySQL. Things like how much RAM to allocate to the tables, what size your temp tables can grow to, maximum number of connections, and whatnot. We have one parameter group per replica or per function. And this is something we're just starting to roll across our fleet. And so, like for example, our ad hoc queries, they have very large temp table sizes above what's usually recommended, because we don't care if they run out of RAM since they're not in the user workflow. Another feature that's not on this slide that's new is promoting a read replica to a master. So during the last Amazon outage, this came in very handy because this AZ was affected and that had our master in it, and it was like, well, do we wait for the AZ to recover? We don't know how long that's going to be, or do we fail over to another AZ? So we made a decision, push the button that this read replica in AZB is now master. We go and set up our replicas, and our site is back up, and people can post and share and whatnot. Metrics collection. So Amazon is really good at providing the underlying CloudWatch. So you get things like CPU usage, RAM, number of connections. I would recommend also having like a database or an app level stats, something like Collecti or Cacti or Monyog, so you know what kind of queries are happening on your databases, what's in your cache, how long those queries are taking. Another tool we use is the Percona toolkit for schema management. And something we've learned the hard way is if you have a complex query that's something like select star from inner join, outer join, outer join, select star from, and that needs to be accessible by users, rather than having when a user clicks on the web page, run that query, if you can, run it from a cron job every couple minutes and normalize it into one table. So what the user sees is just select star from this table. And finally, it's very important that you know your application and know your data. Sundar touched on this a bit. RDS abstracts and simplifies the underlying infrastructure, so you don't have to worry about the hardware or the OS or the MySQL patching. But you do have to know your app and how your app interacts with your data set and how your users interact with that app. So that's something I would say recommend is know your app, know your data set, and know how RDS can help, know how Amazon can help you use those things. So if you know your app, then you can utilize Amazon services even more efficiently. And that's all I have. Let's see what the next slide is. So next up is Jay Edwards from Obama for America. Thank you.
Well, hello, everybody. I'm glad you could join us today. I am going to talk about how Obama for America used AWS. And specifically, I'm going to focus on RDS and some of the problems that it met for us. And I'm probably going to talk about DynamoDB a little bit because it's pretty amazing. I was the first dedicated DBA at Twitter, which means I went from like one database to hundreds and hundreds of databases. I was the lead database engineer at OFA, which isn't as impressive as it sounds because there were only 2 of us. Some of the problems, or if we talk about Obama for America, you've probably been reading some news articles, you've seen some stuff on the web. We were very technically sophisticated for a political campaign. That does not mean that we were what you would consider like Silicon Valley technically sophisticated, right? We weren't maintaining our own branches of MySQL. We weren't committing code to open source projects. The universe of people that we were trying to reach was not what you would consider web scale, right? Let's say there's 220 million people in America that are eligible to vote. Maybe half of those people are actually registered to vote. And maybe we're trying to reach 70 million people. This is not by any means what you would consider just, billions of users crushing our website on a regular basis. What we did have was what I call hockey stick plus growth. You can look at what we did as in an 18-month period. We started from 0, and we built a startup that raised $1.1 billion, of which about $690 million of that was online and through mobile applications. And then we tore everything down and went home. We were also particularly sensitive to downtime. Now, as you can imagine, being an early employee of Twitter, downtime, I'm like, whatever, The president does not think that way. There were times where I'm like, if I could take 2 minutes of downtime, I could upsize this RDS instance, and we would have this vertical scale, we would have more RAM, we would have more CPU, and it would be great. And they'd be like, nope, you can't do that. If you're down for 2 minutes, that means the website's not taking donations for 2 minutes, and that means that email that we sent, and I'm sure some of you got some of those emails, that's tens of thousands of dollars or $100,000 of revenue and donations that we won't be able to take. So you need to fix your problem a different way. You might have seen this graph, and unfortunately I don't have a particularly informative y-axis for you. But this graph measures the growth in the number of calls made by what we called call tool. So this was, you could get on our website, you could dial a number, and you could read a script to somebody about why you should vote. And that's not a hockey stick, because I've seen hockey sticks. Was anybody here at the keynote? Did anybody make it to the very end and get to see the OFA architecture slide? All right, this is about this big, right? You would need 3 slides to display the entire architecture diagram. This is particularly an application called Narwhal, which is, it's OFA sort of like middleware. Maybe you could think of it as sort of an enterprise service bus. We move data around from here and there. We had 200 applications that look about like this. You can see we've got some RDS read replicas. We're synchronizing across AZs. There we go, RDS read replicas. We're using ElastiCache. We're using DynamoDB, which, by the way, if you're doing 100,000 writes, you can do 100,000 writes of 1K items per second. You know how amazing that is? And I actually would do statistics. I'd be like, I have to load 300 million records in Dynamo today. I would crank it up, and it would be like, the longest it took to write 25 records was 6 milliseconds. So if you have some very write-intensive or read-intensive workloads, Dynamo is amazing. Now, what are the problems that we had at OFA that you probably have too? You're always going to need more databases. We had just in production, we had over 100 RDS instances with 24 separate schemas, 30, supporting different applications. Everybody here, I assume, works someplace that has DBAs. How many of you have enough DBAs? Okay, nobody has enough DBAs, right? Well, some lucky guy over there does, but I'm not counting them. So we had 2 people that could spend maybe half of our time doing kind of MySQL administrative stuff. So you go back to that 18-month time frame, we really had to optimize for operational efficiency, right? I couldn't say, hey, I got to spend 3 days building some replicas. I have got to take a snapshot of this database and restore it over there so somebody can run some crazy ad hoc queries. It's just, we didn't have the time and we didn't have the resources. So instead of using MySQL on EC2, we used RDS. And people have talked about it. Kimo's talked about it. Sundar's talked about it. It is really like clicking a button. You're like, oh, man, I'm getting some more read load. I need another replica. Click the button. There you go. You got another replica. My hardware. Now, the hardware can take a few minutes, but you're like, I need to add another 500 gigabytes of storage space. I need another 10 gigabytes of RAM. You click a button, and you go get your coffee, and you come back, and it's done. And it's really hard to overstate how that changes the way you think about things. When I worked at Twitter, a lot of times you'd be like, oh, we need to increase the number of read replicas. And that took some time. You couldn't just add 3 read replicas and 30 minutes later say, hey, everybody, my read replicas are up. You can start sending traffic to it. Point-in-time restores, also, click the button, which, if you've ever done a point-in-time restore with MySQL, is not something that you're just like, I'm going to go do that right now. Hey, we're ready to go. I've got you that database the way it looked last week. There, however, are some times you should not use RDS. The first one is you can get much larger EC2 instances than the current largest RDS instance. So if you think to yourself, I need 32 cores and 62 gigabytes of RAM on my MySQL master, you can do that on an EC2 instance. I might suggest that you need to grow out horizontally if you're in that case, but maybe you can't do that. If you have very sophisticated use cases, my favorite is the frequent topology changes. I was a real big fan of that at Twitter. If you want to do something like master-master replication, which I don't recommend you do, by the way, but if you wanted to, you couldn't do that on RDS. If you wanted to, for whatever reason, promote a slave to a master and rehome all of your existing replicas off of it, you can't do that with RDS. And finally, if you need to replicate from the East Coast to the West Coast because you're worried about hurricanes, you can't do that, but it is on the roadmap. Sundar says it will be done very soon, or sometime. And finally, your DBAs need stuff to do. Right? They're spending too much time on the internet. They're on Reddit too often. Go ahead, use MySQL. Give them something to do. And I will, of course, be taking questions after all of this. But I would like everybody to give it up for Andy.
Andy Scallett. I'm doing the awkward Movember mustache section of this session. No. So in all seriousness, I'm CTO at Brand Verity. A little background on us. We find affiliate fraud. So it's a needle in a crawling and social media haystack. A lot of data coming in, and we're working on behalf of companies like Netflix, Intuit, and Zappos to help them find which of their marketing partners are doing a good job and which of them are defrauding them. We have kind of a modern startup model. We've been around almost 4 years, but we're bootstrapped. We deal with big data. We have a small team, and we have no dedicated operations staff. So that changes the way we look at things a little bit. We also make the assumption that new products may fail, and that's just part of our business model. We also look at ops time and dev time as equivalent because we don't have operations staff. Obviously, developers end up dealing with production issues when they come up. Given this kind of framework, we like to work with managed services because when you're developing against managed services, you have to consider the constraints that they have. They will have constraints. But once you've done this, you're kind of free to, well, maybe sit on the beach with a beer, who knows, because you don't have to do that admin. So for new products and markets, I would say YesSQL. You can handle things like CEO queries, which many of you are probably familiar with. Like, oh, can we look at the slice of data from Florida from last December when the weather changed and whatnot? It's very hard to answer those questions when your query model is constrained, but with a relational database, you have a lot of flexibility there. So do you think you have big data, Punk? Well, even if you do, it might be worthwhile to prototype on RDS, which is something that we do because we understand that the new products may fail. We can get along with an RDS instance or a set of RDS instances for some time to kind of see whether that product's really going anywhere. And if it is, then we can invest further into a NoSQL solution. If you're doing that style, you can use a MySQL on RDS as kind of a big table access model where you don't have a fully normalized database. You just work with a single table, and that can make it easier to port to a NoSQL data store down the road. That said, RDS instances have grown quite a lot in their I/O capabilities. We've seen provisioned I/O coming out, and also SSDs have changed that landscape a lot. So like for us, what we could get away with a few years ago on RDS, well, on MySQL on EC2, on EBS at the time, RDS wasn't around yet, has really, that landscape has changed, and it's given us a lot more capability without having to bust into the NoSQL toolbox. Other data stores do have that more constrained query model, as I mentioned. So if you do have big data and you're going to have to go outside of RDS to solve your problem, or outside the relational database world, you kind of have to think about how to cast your problem. What's your access model? So the simplest is your key value store, right? And we know your query is a key and your result is a value. If you can do that, you're in good shape because that's an easy to scale access model. Beyond that, you may need a column store where you are querying on multiple columns specific values, like city is Seattle, vehicle is bicycle, and then you get the results back for that. Those data stores are a little bit harder to scale. Obviously, beyond that, you could have a full SQL data store, which gives you even more flexibility. But this, casting your problem like this is hard before you know the use cases. So if you're prototyping a new product or you're working with new customers in a different type of business, it's often very hard to figure out exactly what the access model that they're going to need is ahead of time. And this limits your mobility as you're building new products. So as far as AWS options that are out there, obviously we've seen S3 key value store. You're probably all very familiar with that. It can handle very large objects and has excellent performance considering the size of objects that you can handle with it. ElastiCache is a great option for smaller data sets. If you've used Memcached, then you'd be very comfortable with ElastiCache. But your working set has to fit in RAM on the size ElastiCache instance that you're using. So the data set size is constrained in that way. Dynamo is an excellent new option, still very fast, and allows you to, it's sort of a key value store plus in that you can just use it as a key value store, but you can also use it as a key in combination with a hash key and range key combination, right? So if you want to do like posts by a user in a date range, you would use the user ID as the hash key and the date as the range key. And then you would be able to query on both of those, which can be really good for certain use cases, but it's still not a full column store. SimpleDB actually has a great column store API, similar to what I described in the previous slide, but it tends to have trouble with the set intersection component on larger data sets. So we're looking forward to the future options from AWS in that column store area. Obviously, RDS we've talked a lot about already. So an example of case study in our business is crawl history. So we crawl about 8 million pages per day, and we have certain rules about how frequently to crawl them. It doesn't make sense to recrawl a page if you've just crawled it in the last hour, for example. So we've got about 25 million unique URLs at any given time in that store. Fortunately, it's a key value model because we can use the URL as a key and then store the date that we actually did that crawl in the value. So we started by solving this problem with Cassandra, which granted has developed since we worked with it, but it's as a distributed system, you have a lot of maintenance to do to handle make sure the nodes are talking to each other, or if you need to scale the system up, you need to know how to add the nodes, where they fit into the ring and whatnot. So for us, it wasn't worth it really to do all that admin work for this use case. But we turned out to be punks because we figured out that we could have fit the working set in RAM on a large instance. So we figured, hey, let's just throw it in a Redis on a large instance and get rid of this distributed system headache. Later, though, that store had scaled up until it didn't fit into RAM on an M2.x large. And at that point, we were looking at scaling vertically to an instance with 30 gigs of RAM or something like that, and it wasn't very appealing. Fortunately, at the same time, we participated in the DynamoDB beta and were able to migrate the data to DynamoDB, which totally got rid of our admin. All you need to do with DynamoDB is set what your provision throughput is. So once we had that up and running, it was like a whole part of our system that we had to admin went away. Another case study I want to share with you is our ad data. So we pull about 10 million new ads per day and follow about 7.6 million redirects. So we have to store individual records for each of these for our customers' purposes. So do we store all of this in MySQL? We probably could on a big RDS now, but a few years ago it wasn't, with EBS it wasn't really possible on a single instance anyway. So in the old days you'd buy a big fire-breathing disk array and hook it up to a big box and go that route, but this is the cloud, and we're not working that way anymore. So what we've done is we've taken a hybrid approach to the way we store our data, and Sundar alluded to this in another slide, you can get the best of both worlds by really using NoSQL for some of your data and a relational database for other parts of your data. So for us, we take our high-value, low-volume data, like the relationships between websites and merchants and the IDs that they're using to track them, and store those things in the relational database. And then we take our repetitive data of all of the occurrences of things that we've discovered and store those in a big data store. What we're doing is based on S3, we take the full day's results and serialize and compress it in JSON at a natural key, and then we filter the columns of that data on retrieval. So that's our own custom code. It's great in that S3 scales perfectly horizontally, and we don't have to worry about that. But there are more modern options now, I think, in terms of big data stores that require less development. So in summary, I encourage you to spend your time on development rather than operations by leveraging managed services. RDS is a great option for prototyping and for that high-value data that you're often going to run into CEO queries on. S3 is extremely robust, and you can do the trick that we're doing by pre-processing data that goes into S3 and to kind of slice it into a format that's close to what your customer wants to see. Or post-processing, like doing filtering on the output side, allows you to use S3 in ways that, beyond the kind of typical video or photo storage model. And then try DynamoDB. If you haven't yet, it's a very powerful option. You have to understand the constraints of the key value store access model or key plus range access model. But we found it's been very low cost for us and fast, and we're comfortable with the persistence as well. Kind of looking forward to the multiple column queries on big data, having an Amazon managed solution for that. And I'm very excited to check out Redshift and see where we can fit that into, or whether it's a fit for our business model. So if you have any questions or comments, feel free to email me. And we'll do a Q&A now, I think, briefly with Sundar.
Thanks, Andy. For those of you who want to ask questions, raise your hand. I'll bring my microphone over. And on the stage, we have a microphone as well. Do you guys have any questions? Okay, there's one here.
Just a quick question on the Redshift product. If we start with DynamoDB or one of the other products, do we have to move that data over into the Redshift data warehouse, or will that be able to access these Dynamo and other products?
Question was about Redshift and DynamoDB as a data store. There is a pre-built integration where the data can be automatically moved from DynamoDB over to Redshift. So the data will have to be in Redshift, but there is a pre-built integration. Hopefully I won't trip and fall.
Hi, I was wondering if any of you are running multi-region and how you're dealing with the data consistency across the regions.
Region, and basically we did a custom synchronization tool, which is how we dealt with it. I mean, there's no real replication across regions. You just can't do that. So at the moment, you could use MySQL on EC2 and set up a WAN across regions, like OpenVPN, and that would probably be my recommendation now.
Question here.
I actually have two questions basically to you actually. So the multi-region replication with RDS, is that coming soon? Like, is there a timeline for that? Second one is there any plans to support sharding and some kind of horizontal scalability within RDS?
Multi-region replication was one question, and then the second one was sharding. It's a hard problem, as he described. We are working on the infrastructure to get the data replicated. I can't give you, we typically don't talk about future releases, but it's on our roadmap to get it done in a soon enough fashion. Second one is about sharding. Again, another big problem. The issue with sharding is not necessarily just the sharding, it's actually the resharding when you decide to do the resharding. So we are thinking through that. It's also on our roadmap, perhaps on a longer time horizon than cross-region.
So do you suggest, do you suggest any approach if you have a complex schema, complex access, like it's not like a key value pair, but it's a complex access and complex schema, and still there is a need for scalability? Do you suggest an approach? Because I don't think we can use any existing.
Actually, I will turn it over to Jay. Since Jay, you have used, the question is really about complex schema or their approaches that you, scalability. Complex schema with scalability as a, how do you achieve that?
Okay, can you actually restate that question again? I'm not hearing you very well all the way up here.
I think the question is, if you have a complex schema and you want to achieve scalability, what are the techniques and approaches that we would use?
One of the most common ways that people with very complex schemas end up scaling is really, I mean, you shard. You just pull out table sets and put them on separate databases. The other thing I've seen, and I think Delicious used to do this kind of pre-Yahoo, was they would have the same database schema, you know, like replicated 10 times, and they would just index each one differently based on the query access patterns. But if you're doing something like, you know, what I consider consumer internet facing, a complex schema is just going to kill you. You know, if you're trying to do inner, outer, sub-select, correlated queries to answer questions from people coming in on the web, you're just not going to be able to do it. You know, it'll work for a little while, and then you're going to spend all your time like trying to denormalize and just make simple queries. I think, you know, kind of pre-populating tables with queries that you expect people will do, and techniques like that.
So what do you suggest about directory lookup, that if you have sharded your system based on user IDs, would you recommend using directory lookups to locate the user and going after that, or would you suggest fixing the IDs to not changing the users across shards?
A lot of that really depends on your application, right? So the question is, if you have a sharded schema and you have user IDs, is it best to kind of shard on user IDs? Is it best to attach user IDs in some other fashion? And that really depends on, you know, like everything else, it depends on your application, right? Where do your queries generate hotspots? And, you know, if you have, you know, at Twitter we use sequential integers for user IDs for a long time. And that meant that, you know, unless we did some hashing at the application layer to distribute those out, you know, there were always, you know, user ID based hotspots. It was the same thing when we did, you know, sequential IDs for statuses, for tweets, until we started using, you know, a unique identifier that just hashed better. So it can work to just divide everything up by user ID. It just kind of depends, which isn't very helpful.
Question for Andy. Just curious what real-world read-write performance differences you guys saw between Dynamo and Cassandra.
Between Dynamo and Cassandra, you know, the transition, we had a Redis implementation in between, so we never did a head-to-head between Cassandra and Dynamo. But if you're willing to pay the price for the higher provision throughput on Dynamo, it would be hard. There would be a point where it would be hard for Cassandra to keep up, if that makes sense, because you can scale up the provision throughput on Dynamo to very high levels, and I'm not sure exactly what magic they're doing in the back end to make that all work, but I think the scalability is stronger there.
Yeah, this question is for you. I'm just wondering, if I use DynamoDB and use VPC, can I use DynamoDB within the VPC environment?
Question is, can I use DynamoDB within a VPC environment? I should know the answer, but I don't. I'll find that out for you. A particular detail escapes my mind right now, so I'll get that back to you. There is another question.
Yeah, question for Kimo. On your slide, it showed that you had your master databases. It looked like they were EC2 instances where your read replicas were RDS, and I was wondering why you made that decision.
No, they're RDS instances. Probably the slide just didn't come out right. But we're all, MySQL for us is all on RDS.
Okay, thanks.
Okay, there's one in the front. Let me see.
Is Postgres on the roadmap for RDS, or do you recommend for or against using EBS for that?
We always evaluate these different engine choices. Really, a lot of it is driven by customer demand. We have been hearing consistently higher volume of demand. So it is something that we are actively looking at it. Unfortunately, we don't comment about the timing of it, but our goal is to satisfy that user base in a shortest amount possible. So I know I'm not giving the perfect answer, but that's the PR approved answer. So. Well, it's actually a design choice. There are two storage choices on EC2. One is direct attached, where you are taking care of all the different backup and restore mechanisms using the local disk. But you also have to recognize that upon reboot of the instance, the storage is ephemeral in nature. Then the network attached storage, which is what EBS is. And it gives you the ability to detach the instance and reattach the volume and have recoverability in a different model than a direct attached. That's a design choice really up to the individual application. Some are doing very well with direct attached. Some are doing very well with network attached. EBS is doing well and it's getting better. They are working on some really good reliability and durability, other techniques and scalability techniques. So I wouldn't be surprised a year from now, we think about EBS in a very different way than we may have thought about.
The question to the speaker in the Obama campaign, you said that DynamoDB was an amazing product. What makes it so compelling?
So the really amazing thing Andy talked about is the operational overhead of maintaining your own distributed key value store is non-trivial. It is difficult. It's, whether it's a Hadoop cluster or a Cassandra cluster, that's a lot of work and that's a lot of monitoring, and you have to understand, it's the same thing with Redis. I mean, you have to understand what that cluster physically looks like and how the data is on it to use it efficiently. DynamoDB, you're like, click, more writes. You wait for it to scale up and you do more writes. I will say that you have to monitor your costs closely, right? You pay for what you have provisioned, not for what you use. So I did that every day. I would here's my 80 DynamoDB tables. What has been the peak over the last 24 hours? Let me scale that down. Let me scale that up. But it's really, just the operational ease is amazing.
So in addition, I think we're working on some scripting too to do that, because there are good metrics coming out of DynamoDB that publish to CloudWatch, so you can see what your utilization is. And so we're doing the same thing. Hey, check my utilization, maybe scale it up or down. But it's certainly possible to do that in an automated way, which takes your admin of your key value store basically to zero.
Hi, my question is about RDS MySQL monitoring. So I'm curious, you mentioned Monyog and some other tools. Are you depending to identify specifically query hotspots, like the general query log and the slow query log, or are you using a proxy and packet sniffing, or how are you solving that problem?
So we use Collecti and Monyog to do types of queries, like number of selects per second, number of inserts per second, number of updates and whatnot, and see how our query cache is going, like what's in the cache, what's being evicted. And so we look at the graphs, and we have monitoring for if our read latency or select latency, or rather our slow query logging is showing many queries above some number of seconds. We'll get alerts off of that. And so with RDS, CloudWatch, we see the underlying, and then we do need that other layer on top to get those kinds of stats and hooked into Nagios and whatnot. Did that answer your question?
One last question. We'll be available here for more questions. I don't want to hold others back for the next session.
So in DynamoDB, there is a size limitation. So I cannot store more than 16 kilobytes. So how can I overcome that? And also, there's not really good query mechanism for DynamoDB. So what kind of other solution can I use?
So with DynamoDB, I mean, the query mechanism is fixed. It's either a key value store or the key hash key plus range key value store. So really, you have to cast your problem in a way that fits that query model. There at this point, at least, there isn't. Well, okay, I guess you could post-process the data coming out of DynamoDB and do some other filtering, but you're likely not to get great performance out of that. So. Yeah, so that's a good solution. But in terms of, do you want to handle the other piece? Or, yeah, data size.
Right, so Dynamo has a limit, I believe it's 64 KB per row. That also counts the column names, right? Because it basically returns a JSON blob to you. And the only way you could get around that is to do the same thing you're doing with Couchbase and Dynamo. It would be like looking up blobs in a regular MySQL database. You get some URL that points you to where the data really lives. So you have the key value store, and the value is look up this path in S3, and yeah, which is what a lot of people do. S3 is definitely not as fast as S3, but I mean, you can't, there's no data store where you can say, hey, I want to store 10 megabyte items and have them come back to me in a millisecond, right? You just can't. So I mean, that's the trade-off you have to make with your application. You can say, all right, we're going to have a boundary of 64K, and that's the data size, or you can say, we'll use some other system that can store larger objects and just deal with the latency hit for that. Maybe do some kind of caching. There are just a lot of ways around it, but I mean, you have to adapt your application to the technologies that exist, right? It doesn't work the other way. It's going to depend,
Well,
sorry, just briefly, a solution that we use to that problem is we have, like, if we have users doing reporting, we say maybe there's 10 columns that they care about that have relatively short data. We fit that into the DynamoDB record, and then there will be further details that get stored out into S3. And so the way we handle that is they either need to drill down to a detail page that actually does pull the detail for that specific record from S3, or we'll do some AJAX and kind of populate the details on that page, which I'm not saying is the best solution, but it's a way to kind of balance the two latencies and still get good performance for the user.
Well, thank you so much. We'll be around here, so I wanted to thank you everyone for attending.
Yeah, thank you.